Hi everyone, this is the Beer Watcher. It is March 12th, 2017. Sorry I haven't made any videos lately, but I was gathering evidence of the patterns that we're seeing in the sky. This was taken over Lake Starnberg. I was using this as an example for what I'm going to show you a little later in the video. I want you to notice these sundogs that as this planet approaches will fade and we're going to get more of a darker shadow. And I'll explain why this is happening. The pattern that I'm seeing here was this photo was taken in California with an early sign of the halo. We can see this dark halo here. No longer seeing the sundogs like we saw in that first video because it's getting closer. Whatever it is, it's blocking the true sun. This was 6 days. And then after the 6 days, we had 3 days of sunny skies, no chemtrails. And then on the third day, we had 3 straight days of chemtrailing. Yes, sir. Look at this halo now, high in the sky. We can play this video real quick. Not at 22 degrees. Sorry, it's a short video, but let's get to the next point. You've seen this before in my other videos. This is the second day of the 3rd straight chemtrails. Another sun halo. Look how dark it's getting now. So is that the new pattern? 3rd day, darker yet. So I suggest to you that that may be the new pattern. 6 days of clear blue skies, 3 days of chemtrailing with halos that are getting darker, no longer getting the sundogs. Why? Let me show you. Let's get right into it. So let me play this little demonstration here that I made using a flashlight, being the sun simulator, and the light in the background being the real sun. Let's watch this.
Let's say the light that you're looking at on the ceiling is the true sun, 93 million miles away, with its light approaching the Earth at straight lines, not angular. And the fake sun, which is in a heliosynchronous orbit, rotating and orbiting around the Earth at 256 miles above the Earth, always in front of the sun. Okay, but the problem with this, that the light from this sun simulator that was launched probably by NASA, orbiting like a satellite from the space station, from the space shuttle, that this light is approaching the Earth from an angle, or like at a cone, so that when clouds at high altitudes pass in front of it, the sun looks small. And when clouds pass at a lower altitude, the sun looks much bigger. Low altitude bigger, high altitude smaller. I hope that makes this easier to understand. Again, how did it get there? By NASA from a rocket with a lens in front of it to make it look bigger than it really is. When the clouds passing through, just like this paper does, obscuring the light, making it look smaller at higher altitudes and bigger at lower altitudes. This would not be possible if this was only the true sun. Thank you for watching.
Okay, so next, we've got my explanation of why they've got the sun simulator in the first place. Let's watch.
So let's pretend that this light you're looking at is the sun, and we're seeing it from the Earth, and a planetary body passes in front of it, and we get a solar eclipse. It's one that we don't expect from another planet. We don't want to panic. So let's put a fake sun in front of it. Does that look familiar? Now here's something else peculiar with this sun halo that we've been getting, that if this object was close to the Earth, then we're going to see less and less of the sundogs and more of a darker planet. But if this planet is closer to the sun, then we're going to see more sundogs. You see how that works? So the planet passes in front of it. We still see light. We chemtrail in front of the flashlight. The solar eclipse passes. And now we get a combination of the fake sun and the real sun. Thank you for watching.
Okay, so with that being said, this is what I think that we're expecting soon to see this object. And to further clarify the fake sun and the lens system that it has, I suggest let's go over this one more time of the fake sun and the Fresnel lens and everything that's involved in the fake sun. So let's start with the International Space Station. So here, whether it's reflection or not, a mirror, it doesn't matter because the sun is over on the left. But let's watch, because anybody who watches the space station long enough, we've seen this thing rise like this, and then we get like this strange halo in front of it. Okay, so it turns on and it turns off. We just saw the whole thing completely turned off. Didn't set at all. Is that supposed to be the sun, or is this something mirroring the object? Because if it is, then we may have something more like this up there. This object here that's outside the eclipse of the sun, reflecting the light down through a telescope, mirroring it onto the Earth like this. But where's the Fresnel lens? What is it rotating in front of it? Because I know something's rotating in front of it. And then the lens array, which is separate from it, again, I believe there is something rotating in front of it. I don't know precisely what it looks like, but I do believe it's probably something what you just saw in that last picture. Again, this here would be a rotating object in front of the sun, and we can see this thing in front of these large and small lenses. They're there to obscure the planets, so we can't see them. I'll show another video. Again, we can see the lenses here, and we can see the oscillating light source here going up and down. And we can see all the lenses in here. Pretty damning evidence if you ask me. And why red? That's magenta. Well, that's awfully good color for hiding this object, and how lenses can basically hide a planet. Here's an easy demonstration by pulling it out of focus from your eyes right here. I'll show you. Just put a lens in front of it, pull it out of the focal point from your eyes, and it disappears. Ta-da! And then, to go over this real quickly, I believe this would be the light source, or the mirrored light that comes through, bounces through these mirrors, showing the light path, going through this hole in this circular or hexagonal lens here, bouncing off here. This dot, I believe, rotates. Here is the angular light that approaches the sun, and that's the problem, because when things get close and small, it moves. This is the black dot that we see in all the photographs, like in here, but you got to be looking down the barrel of a gun to see it. You're not going to see it at all angles, like we see in this video taken in webcam to Mexico. People say that this is a camera overload. Oh yeah? Well, look at that. It's reflecting off the water. You're done. Okay? And it rotates. How? Further evidence of it rotating, an FLR infrared camera watching it rotate. Okay? So, hope this helps. If I left anything out, I think I covered all of it. Again, here is an FAA camera, and we can see the projection of it, of the light source itself. Being projected, whether those are mirrors, it doesn't matter. It's still a type of the light source being reflected. And then again, the rotating Fresnel lens in this video here. Actually, I got a better video. Hold. There we go. Here we can see it rotating here. So there is something rotating in the sun. Is that the telescope that rotates? Maybe. Still trying to figure this thing out. Don't know the exact shape. It's up there in a heliosynchronous orbit above the Earth, 250 some odd miles, and a low orbit. So here is a quick drawing of basic layout, not at all to scale. So you have a sun, you have the eclipsing planet, you have the sun simulator, this would be the black dot, these are the lights, we have the lens array, and then we've got the Earth. And this drawing here, I try to make it simple as I can, but with the sun simulator, the light approaches at an angle. So if we put an object at this altitude, then that will be the new diameter of the Earth. But if this were the true sun, that would not be the case, and we would get, so like our true sun, we would have our sun here so much bigger than our puny little planet that although the light is coming off from an angle, it is so large it's relatively straight from the distance. So it should not be fluctuating in and out of size so easily when the clouds pass at low altitudes or high altitudes, and you will find them in the videos, and I will show them to you at a later time. So again, the object being closer to the sun and the object, if I can find it, so the difference between the sun, the object being closer to the sun, and the object being closer to the Earth. Closer to the Earth, closer to the sun. 6 days between 3 days of chemtrails. Watch for the pattern. Tell me what you think. Copy, like, and share this video. Thank you for watching. Have a blessed day. See you at the Lord's Supper.